Okay, on to the next section. Describe the characteristics of this graph. So I have this function. F of x is x squared minus 9 over x squared minus 25, and I'm going to use that to answer all of these questions. So although it doesn't ask me to graph it, really I need to think about what the graph of this looks like in order to answer all these questions about the intercepts, the holes, the asymptotes, the end behavior. So I probably want to think of it in factored form. The top factors into x minus 3x plus 3 because it's a difference of squares. The bottom factors into x minus 5 times x plus 5 because it's also a difference of squares. Let's go ahead and put that into our calculator. I'm going to clear that out. I've got x squared. I do not like to type it in factored form just in case I made a crazy mistake when I was factoring. And then I've got x squared minus 25 and a graph. So my graph looks like it has 3 pieces here. It has a branch up here on the left, and then one of these upside down U shapes, and a branch over here on the right. Question A asks me about how many x-intercepts and how many y-intercepts there are, and what are they? So looking at my picture over here, for the x-intercepts, I'm going to cross here, and I'm going to cross here. So that means my graph has 2 x-intercepts. For my y-axis, I only cross once right there, so that means I have 1 y-intercept. Now let's figure out what they are. It looks like in my picture that it's crossing at -3 and 3. The easiest way for me to figure that out would be to go to trace. I can type in -3, and I can see -3, 0 is in fact the point. And then I could type in +3, and I can see +3, 0 is in fact a point. I knew that without even looking at my graph because I know 0 divided by a number is 0. So when the top of the fraction is equal to 0, that's when I'm going to have x-intercepts. So +3 and -3 are my 2 x-intercepts. -3, 0, +3, 0. Okay, I know that for my y-intercept, my x value is always 0 in my y-intercept. So if I'm trying to figure out what my y value is, I could just go plug in x equals 0 right here. And I'm going to get -9 over -25, which will reduce to 9/25. I could also use my calculator to find this. In trace, I just type in 0. It gives me 9/25. If you gave you the decimal version, that would be fine too. All right. Question B, the graph has a hole at. Well, in order to have a hole, the top and the bottom would need to have a factor that reduce. So I'm going to say none. There's no hole in this one. The graph has a vertical asymptote at. The vertical asymptotes are where the bottom equals 0 that don't cancel out. So I have 2 vertical asymptotes, one at 5 and one at -5. I can confirm that in my picture. If I were to type, I'm tracing right here. So if I type in 5, I can see it just says y equals nothing. It's leaving that back. If I go in my table for 5 and -5, it will say error. But in my graph on TI, it just leaves it empty. If I type in -5, whoops, I didn't hit trace. So let me hit trace and then type in -5. We can see y is empty because it doesn't exist. All right, the horizontal asymptote. To tell the horizontal asymptote of my graph, I want to look at just the big powers of x, the degree of the top and the bottom. If I did x squared over x squared, that would reduce to 1. So y equals 1 is my horizontal asymptote. If I look over here in my picture, does it look like y equals 1 looks good? Yes, it does. So I'm going to stick with that. All right, I also should realize that as x approaches -infinity, that means what's happening on the left end down here? Well, that's what the horizontal asymptote is. It tells you where it's leveling out. So whatever you have for your horizontal asymptote, that should also be your end behavior. And on both of these ends, the graph leveled out at 1. All right, let's look at number 7. The graph of a function f of x has a vertical asymptote of x equals 6. It has a hole at x equals -5 and a horizontal asymptote of y equals -8. Which of the following describes the end behavior as x approaches infinity? Well, we should realize that end behavior is telling us what's happening over here on the left and the right side of the graph. So that's going to be, where does our graph level out as a horizontal asymptote? That was y equals -8. So y approaches -8 is my end behavior for either positive or negative infinity there. All right, question number 8 goes back to this f of x that we had up there in question number 6. It says find the range of f of x. So I have my picture right here. I can tell that these two branches on the top, y was above 1 because that was my horizontal asymptote. So I have y such that y is greater than 1. I don't actually equal it because it was an asymptote. Or I also have this piece right here where I have to be less than or equal to whatever this peak is. I'm going to put a less than or equal to there because I actually touch that piece. Now I have to find that maximum, so I'm going to do that on my calculator. I'm going to calc the maximum. I need the left bound, so I need to be somewhere right about here. I hit enter. The right bound, I need to go over to the right side of my peak, and I hit enter, and for my guess, I want to be somewhere in the middle. This looks nice and symmetrical, so I'm going to guess it's when x equals, this is 0, right? -1 times 10 to the -6. So that's 0.00000, in other words. Y, whoops, was 0.36. So my y has to be less than or equal to, come back 10, 0.36. All right. On your test, this would be a multiple choice question, and you would have to recognize the type of range and which values make sense. Okay. Let's look at number 9 here. On number 9, it asks you for the domain. The domain, I can never equal 0 in my denominator. So x such that x is not equal to, if I set this first factor equal to 0, I'm going to get -3/2. If I set the second factor equal to 0, I'm going to get 1. And realize it doesn't matter that all these guys would reduce out. Those would still be holes in the graph, but there's still restrictions in the domain. They're excluded values from the original function. Okay, do I have anything else on this page? No. All right, jumping over to the next one. These are the characteristics of the graphs. So I've given you the picture, and we're going to state the requested information using proper notation. So first I'm looking for the vertical asymptotes. It looks like I have a vertical asymptote right here at x equals -3. If it's close, you can assume it's probably the integer value. The horizontal asymptote, looking at my picture, I think I'm leveling right here at -2. So I'm going to have y equals -2. All right, when I go to do my domain, my only problem is this vertical asymptote. So again, x is not equal to -3. And when I go to do my range, my only problem is this horizontal asymptote. This guy's down below, this guy's up above. So I'm going to say y is not equal to -2. I'm going to jump down to the end behavior while I'm here because my horizontal asymptote, my range, and my end behavior should all involve those y values that came usually from this horizontal asymptote. All right, increasing, decreasing. In order to be increasing, I have to be going up from the left to the right. If I draw from left to right on this one, this piece is falling, and this piece is also falling. So this is never increasing. It's only decreasing. I have to write each piece separately. The left side of the graph is from -infinity, and it keeps decreasing until it hits this asymptote, which was when x was equal to -3. For my second piece, it starts over here where this vertical asymptote is. So it starts at -3, and it keeps going forever to the right over here, so until x is positive infinity. Okay, now it says write two different equations that could represent the graph from number 10 above. Well, if you're starting from scratch and writing equation, you know your parent function for this thing was 1 over x. But we've done some moving. We've moved our graph 3 to the left to get this vertical asymptote. To move 3 to the left, I put an x plus 3 on the inside. I've also moved my graph down 2 spaces to get my horizontal asymptote. To move down 2 spaces, I want to put a -2 on the end. By the way, on your test, this will be multiple choice, so you could look at them and figure out which one matches. So that's my first equation. For my second equation, if I went ahead and combined like terms with this one, I have 1 over x plus 3 minus 2, I just get a common denominator, x plus 3 over x plus 3. So now my denominator is still x plus 3. On the top, I would have 1. This is, I like to call that minus 2, right? Minus 2x. And then distribute again. Minus 2 times 3 is minus 6. So my final answer is going to be negative 2x minus 5 over x plus 3. And I need an equation, so I want to put some sort of y equals in there or something like that. I also could have left the top factored out as a negative times 2x plus 5 over x plus 3. That would have been fine as well. And again, it needs a y equals if it's going to be equation. On yours, it's multiple choice, so just be sure you look at all the answer choices and you get the one that makes the most sense, or more than one if it's select all. All right, for question number 12, again, same type of thing. This one starts out with the zeros. I need to know that the zeros and the x-intercepts are the same thing. That's where do I hit the x-axis. Looks like I hit right here at x equals negative 5. I'm going to write my 0 as x equals negative 5, and I'm going to write my x-intercept as negative 5, 0. It looks like I also hit right there at negative 3. So I have a 0 at x equals negative 3, and an x-intercept at 3, 0. To find my y-intercept, I'm just looking where do I hit the y-axis. It looks like it's hitting at 1, but I really think that 1 is probably my horizontal asymptote. So I'm going to say 0.9. You could argue about this value right here. It's not going to be exact. So long as you're somewhere close to that, we're fine with it. All right, my vertical asymptote. Vertical asymptote is going to be right between these two pieces, which is x equals negative 4. Make sure you have an x equals for that. And for your horizontal asymptote, we already put that up here. We said was y equals 1. I'll be sure you have a y equals there. All right, the domain of this graph. The only problem in the graph is this vertical asymptote. So I have x such that x is not equal to negative 4. Now for my range, usually I had one branch down and one branch up, but both of these branches were below the asymptote. So when I write my range, I'm going to have my y is less than 1. I thought my asymptote was at 1, so I'm going to be less than 1, and my y-intercept was a little less than 1. Be sure that you're not equaling the value of your asymptote because it doesn't look like it's actually touching it. All right, as far as our end behavior goes, that same value is showing up again of 1 because on the left and right, the graph is leveling out at y equals 1. Increasing and decreasing. The first piece for this function is falling, so that's a decreasing piece. It starts at negative infinity on the left, and it goes until I hit this vertical asymptote, which was at negative 4. Now my second piece of my graph on this one, if I draw from left to right, is increasing. So for that one, my graph starts at negative 4, and it keeps going to infinity. All right, over to the next page. We are now starting on the no calculator portion. These are simplifying rational expressions. We're just not going to use our calculator to factor. We're going to factor by hand. Okay, the first question here, number 13, was just straight up to simplify. So I want to factor at the top and bottom. This is two terms. I always look for GCF first. There isn't one. These are cubes. So my first factor is going to be x minus 4 because the cube root of x cubed is x, and the cubed root of 64 is 4. Now remember, in my pattern for the second one, the signs went same, opposite, positive. And then my first term, I square this x to make an x squared. The middle term is the product of these two, so that's 4x. And the last term is this 4 squared, so that's 16. For the bottom, I again have two terms. I look for GCF. There isn't one. This is an x squared, so it's a difference of squares. So it's going to factor into x minus 4 times x plus 4. So that's the first step, is factoring. Now I'm going to reduce. Make sure that when you're reducing, you're not completely blackening out x minus 4 and x minus 4 reduce. I can still see what I factored so that in case you make a careless mistake, I can give you partial credit. What do I have left? I have x squared plus 4x plus 16. I can leave the parentheses or not. It doesn't matter since it's the only thing on the top. And I have x plus 4 on the bottom. I cannot reduce this because this is prime. It cannot be factored, and I can only reduce factors. So that one's done. All right, number 14 is to simplify. It's a subtraction problem. I don't like subtraction. I like to change my subtraction to add the opposite. So my first fraction was y over y minus 4. Now my second denominator here was 4 minus y. Let me put my minus 3 on the top again. I've got 4 minus y. I want to change the order of that. In order to change the order of that, I'm going to factor out a negative and call it y minus 4. At this point, I would probably take my negative and move it up to the top. In other words, I'm saying a negative divided by a negative is a positive. I now have a common denominator of y minus 4. On the top, I just add them together. I have y plus 3. And that's it, I'm finished. I can't reduce anything because these two are not factors, so I can't reduce those y's or anything. All right. Number 15 is a complex fraction. I'm going to rewrite it a little bigger just so I have some space. Again, I don't like subtraction, so I'm going to change it to plus a negative 1. And then down here, I'm going to change it to plus a negative 2x over 2x minus 1. All right, in order to do a complex fraction, I want to multiply the entire fraction by the least common denominator. What is my least common denominator? Right here, I need a 2x plus 1 and a 2x minus 1. So essentially, I'm multiplying by 2x minus 1, 2x plus 1 on the top and on the bottom. When I do that, I'm going to have to distribute this on top to both terms on top and this on bottom to both terms on bottom. So I'm going to write with each term 2x plus 1, 2x minus 1, 2x plus 1, 2x minus 1, 2x plus 1, and 2x minus 1, 2x plus 1, and 2x minus 1. Now that I've done that, I can start to reduce things out. This 2x plus 1 will reduce with this 2x plus 1. My first fraction is now 2x times 2x minus 1. So in order to do that, I'll distribute my 2x. 2x times 2x is 4x squared. 2x times negative 1 is minus 2x. Now over here, I had negative 1 times 2x plus 1 times 2x minus 1. Those are three terms. I can multiply them in any order I like because multiplication is commutative and associative. I would probably put these two together first since they're conjugates. I know I'm going to get 4x squared minus 1 because my middle terms of plus 2x and minus 2x will reduce out. I still had the negative 1 that was out in front, so when I distribute that on the top, I now have minus 4x squared plus 1. On the bottom, I have 1 times 2x plus 1, 2x minus 1. So that, again, they were conjugates, is 4x squared minus 1. In my final fraction down here, my 2x minus 1's reduce out. So I have minus 2x times 2x plus 1. When I distribute there, I have minus 4x squared minus 2x. Now I just need to start cleaning this up some. What do I have on the top? Well, I have 4x squared minus 4x squared, so those two are going to drop out. Then I have negative 2x plus 1. On the bottom, I have 4x squared minus 4x squared, so those two drop out. And I have minus 1 and minus 2x. I'm going to write the negative 2x first and then the minus 1. This looks like something that I might be able to reduce, but it's not. I could leave it like that, so that would be a fine answer. If it were multiple choice, it might not be left like that. They may have factored the negative out of the top to change it to a 2x minus 1, a negative out of the bottom to change that to a 2x plus 1, and then these negatives would reduce. So our final answer that way would be 2x minus 1 over 2x plus 1. Either answer, again, is fine. I probably, if it weren't multiple choice, I would have stopped at this black answer. but I would have turned it into the right answer if that were a multiple choice. All right, number 16, completely simplify the following expression using only the factors provided. Each cell can have one or more factors. So this is like a drag and drop on the SOL, where you're going to take any of these factors and drag them over into the numerator or denominator to get us one fraction in our answer. All right, this is a division problem. I know that for division, I'm going to flip the second one and change it to multiplication. I also know I need to do some factoring here. So let's start out and factor. I've got 3x squared plus 17x minus 6. Okay, this is a little more complicated than just what two numbers multiply and add, so I'm going to put it into a area model because I have a leading coefficient. So I'm multiplying to negative 18x squared and adding to positive 17x. So that looks like plus 18x minus 1. So my GCF of the top row is 3x. X times 3x gives me 3x squared. 6 times 3x gives me 18x. Negative 1 times x gives me negative 1x. And negative 1 times positive 6 is negative 6. So that's good. My first fraction was 3x minus 1 times x plus 6 on the top. All right, I'm going to look at the bottom of this fraction. This was 36 minus x squared. I typically don't like to factor with the x squared second. In order to change the order, I would like to take out a negative and call it x squared minus 36. And then x squared minus 36 is the difference of squares, so that's going to factor into x minus 6 times x plus 6. All right. On the top of the second fraction, I had x squared minus 9x plus 18. When I factor that, it's going to land on the bottom of the second fraction because I'm flipping. So what two things multiply to 18 and add to negative 9? There's no leading coefficient, so I can jump right into my factors here. That's x minus 6 and x minus 3 would add to negative 9 and multiply to positive 18. And then I have one more that I have to factor. 2x squared minus x minus 15. Again, this one has a leading coefficient, so I'm going to go back to my area model. What two things multiply to negative 30x squared and add to negative 1? So one has to be positive and one has to be negative. Negative 6 and positive 5 would add to negative 1. GCF of the top is 2x. 2x times x is 2x squared. 2x times negative 3 is negative 6x. What times x is 5x? That's plus 5. And then my check, plus 5 times negative 3 is negative 15. That's good. So now I've got 2x plus 5 and x minus 3. Okay, now I can start reducing. Now that I've gotten all that done, I can start reducing. Let's see, on the top I have an x plus 6 and on the bottom I have an x plus 6. Any factor from the top can reduce with any factor from the bottom. It doesn't matter whether in the same fraction or they're in fractions next to each other, because at this point all of the top is one fraction and all the bottom is one fraction. So I also had an x minus 3 on the top and the bottom. I cannot reduce these x minus 6's because they're both on the bottom, and that's not okay. I can't reduce that. All right, so let's look what I have in my final answer. I have this 3x minus 1, which I had over here to drag. I don't care about circling it. I just want to be sure it was actually there, so I could have done my drag and drop. I have this 2x plus 5, and I have that, so I could have dragged that over. On the bottom, I had this negative. When I look in here, I can't write just a negative, but negative 1 is the same thing. So I would drag over negative 1 on my SOL test. I have this x minus 6 and this x minus 6. So when I drag them over, I have the first x minus 6. Sometimes when you drag, the things disappear. Other times they stay there and you can just drag another one. So I would drag another x minus 6. The other way I might have written the bottom, if it had been an option over here, would be to do an x minus 6 squared. Just watch this. This is not the same thing as 36 minus x squared. We cannot just distribute the squared sign. So this would be my answer. All right, last page. All right, this one we want to simplify and state any restrictions. So let's start by doing restrictions before we simplify, because I can never be 0 on the denominator at any point in the problem. So let's start with this one. If x plus 6 can't be 0, then x cannot be negative 6. I'm going to circle that one. If x plus 2 cannot be 0, then x can't be negative 2. I'm going to circle that one. 4x minus 7 cannot be 0. So if I'm setting this equal to 0, I would move the 7 over by addition and then divide by 4. So x can't be equal to positive 7/4. And then I have one more. If x minus 5 can't be 0, then x can't be negative 5. And there's that answer. Now I also need to reduce these. It's a multiplication problem, so any factor of the top can reduce with any factor of the bottom. So I have an x plus 5 on the top and an x plus 5 on the bottom. Those reduce out. 3x minus 5. I don't have any of those on the bottom, so it stays. X minus 6 and x plus 6 and x plus 6. Those can reduce out. X plus 2 and x plus 2. So my final answer is just the 3x minus 5 and the 4x minus 7. I can't reduce anything else because there's no more factors. All right, let's scroll down to 18. Again, I'm supposed to simplify, and I've got the drag and drop type of answers right there. So in order to add and subtract, I have to have a least common denominator. So my first fraction was x plus 6 over x plus 7. I can't factor that at all. And then I had to add, my second fraction was 4 over x squared minus 49. X squared minus 49 has two terms. There's no GCF. So I'm just going to factor by difference of squares, x minus 7 and x plus 7. Now I need to build a common denominator. This first denominator is x plus 7. The second denominator has x minus 7 and x plus 7. So my first denominator is missing an x minus 7. I need to put an x minus 7 on both the top and bottom for balance, and now I can see if I'm checking them off, I have the same factors in both denominators. Now I just need to clean up. When I add two fractions, the bottom stays the same, so it's still x minus 7, x plus 7. It doesn't matter the order that I write them, by the way. On the top, I'm going to have to go ahead and multiply this stuff together. So in order to multiply that, I'm just going to come over here. I have x plus 6 times x minus 7. So I've got x squared minus 7x plus 6x minus 42. When I combine like terms, my minus 7 and plus 6 give me a minus 1x. I had minus 42. In my second fraction, I didn't do anything to the top, so that's still plus 4. So now on the top, I can put these guys together. So I would have x squared minus x minus 38 over x plus 7 times x minus 7. I need to double check. Can I come up with two things that multiply to 38 and add to negative 1? No, I can't. So I'm ready to just write that as my final answer. And if you look, x squared minus x minus 38, that factor is there. And then on the bottom, I had x plus 7 and x minus 7. And both of those are there. So I am finished with that one. Okay, number 19 is the last problem here. It is a subtraction problem. So again, just like all the other ones, I'm going to start out and factor first, although I probably would change it to add a negative 5. My first factor, y squared minus 1. It's a difference of squares. Y minus 1, y plus 1. Then my second fraction here, I'm going to write it as plus negative 5 on top. On the bottom, two terms. Don't forget the GCF. 3 is the GCF. When I factor that out, I have a y minus 1. So in my first denominator, I have y minus 1, y plus 1. In my second denominator, I have a 3. That's missing from my first denominator, so I'm going to multiply by 3 on the top and the bottom. I also have a y minus 1, which this one has. My second denominator, I have the 3, the y minus 1, but I'm missing the y plus 1. So I'm going to put a y plus 1 on the top and bottom because the only thing I can multiply by is 1. Let's just double check my denominators. Minus 1, y minus 1, y plus 1, y plus 1, 3, 3. I have all the parts for my least common denominator. Now I'm just going to simplify. When I add or subtract, the denominator stays the same. It doesn't matter the order I write those terms. On the top, up here, I have 3 times y, which I usually write as 3y. Over here, my negative 5 would need to be distributed to both, so that would be negative 5y minus 5. Now I'm just going to clean up the top, and that would be negative 2y minus 5. And on the bottom, I still have my 3, y minus 1, sorry, y plus 1. I'm running out of room here. All right, so now I go to write my answer, and I'm looking for negative 2y minus 5. But I don't have that down here. I have 2y minus 5. That's not the same as negative 2 minus 5, or negative 2y minus 5. But since they're both negative, I could factor a negative out of the top. I'm going to call it negative 1 because that's what they write over here. And then this would be a 2y plus 5 on the top, which we have. So my numerator is negative 1 times 2y plus 5. And then on the bottom, I still have this whole denominator, my common denominator. I've got a 3. And then I've got a y plus 1 and a y minus 1. Doesn't matter the order I write these. On your SOL, it wouldn't matter the order you drag them. But that's it. We're finished. So come in with any questions that you have.